Hey everyone, I just wrote a Z zeroing script using a movable touch-off plate for the Centroid controller, and I thought I'd show you how it works. So we've got a ShopBot here, a 4-foot by 8-foot ShopBot that's been converted over to Centroid control. And essentially the way, it's probably worth explaining how my zeroing system works. So like when I first turn the machine on and I home it, it homes X and Y, normally hitting proximity switches, and then the Z comes up and it hits the top of the Z travel. So there's actually a proximity switch up here. And then my tools, both my air drill and my spindle, drive over here and they tap this fixed touch-off plate here, and that zeroes them down to the top of the spoil board. Because most of the jobs that I run, I zero off the spoil board and I just type the thickness of the material into my CAM software. So let me show you how that works in practice here. So we're going to go over to MDI and we're going to press Z0 and press cycle start, and you'll see that my spindle, which is the currently selected tool, goes right down to the top of the spoil board. So that means I'm zeroed to the top of the spoil board. Okay? So let's say you wanted to zero to something like the top of a piece of material, say you had like an intricate carving or something like that. And you can't really, this is 1/2-inch plywood, but in reality it might be 0.52 thick or 0.48, and you really want to accurately zero to the top of it so your carving will come out just right. Well, you could caliper it and punch that into your CAM program, and that's certainly a way to do it. Or you could move a fixed, you could use a fixed touch-off plate like this. You place it on top of your material, and you have the bit come down and tap the plate, and we'll measure the thickness of the material for you, and it will set your zero plane. And so I wrote a script to do that, but first, quick lesson in work coordinate systems. So if we go into Centroid and we go to Setup and Parts and Work Coordinate System Table and Origin, you'll see here, these are all zeros right now. Work coordinate systems are like saved places on your table where you can have jobs. So typically the way you'd use one of these things is like, let's say you had a jig bolted to the end of the table. You could zero the X and Y to like the corner of the jig, and you could work out here, and when you're done, you could say go back to machine 0, which is always here, okay? So these are like kind of saved locations. Well, this script uses the Z saved location to actually raise up your zero plane up on top of your material. So when I just jog down to Z0, our work coordinate system 1, which is what we were in, oops, let me get this back on the screen here. Work coordinate system 1, which is what we were in, was set to 0. Okay, so when I hit Z0, it jogged right down to the table. Well, let's say I change that Z to 1, and I save this, and we'll go back to MDI, and we'll jog back down to Z0. So I've changed my Z offset for work coordinate system 1, which is what we're on right now, to 1 inch, but I'm jogging to Z0. And so if we go back and look, you'll see that the bit is 1 inch above the table. Okay, so I've raised the Z plane up 1 inch. So you can imagine, like if you were cutting on 1 inch material and you wanted to zero to the top, that would work for you. And if you look here on the DRO, we're in work coordinate system 1, but our Z is 0 right now, okay? So let's show how this works with the custom script that I made. So let's say you want to accurately zero on top of the material, you would run this script. So here's how it works. I'm just going to take the Z and jog it all the way up like this, and we'll start up the script. So it comes up and it says, drive the machine to the place where you want to zero from. So I'm going to grab my handy little pendant here, and we'll put our material here and we'll jog over to it. So we'll put our X right there. Maybe we'll bring our Z down a little bit, get us a little closer. And now we're ready to start. So we're going to hit cycle start again, and it's going to say tap the plate to the bit to begin Z zeroing. So let me explain what's going to happen next here. So we'll pull our plate out here. So this plate works by completing a ground in between the spindle and this plate. And what can happen sometimes is the wire, I've had this happen to me, the wire can get broken inside here, and if you have the plate under there and your Z starts coming down, and it hits the plate and the wire is broken on the inside, it'll smash up your bed, and it'll keep smashing the plate, and you have to run over and hit stop, and that's not a fun a fun idea. So what I did is I actually set this script up so that it won't start until you actually tap the plate to the bit, and that kind of confirms that the plate is working. So we'll go ahead and give it a little tap, and it starts moving nice and slow, so you got time to put the plate underneath there. And so it's going to give it 2 gentle little taps, like that, and that's it. Screen comes up, tells you to put the plate away, so we'll put it in our trusty little holder there. And let's go back and look at our screen. So the script is over. So let's go back into Setup, Parts, Work Coordinate System Table, and Origin. And let's look at our Z offset for Work Coordinate System 1. That's at 0.51 inches. So that tells me that that material is probably about 0.517 inches thick. Now, let's go to MDI, and we'll do a manual move, and we'll go back down to Z0. Now I'm going to hit cycle start, and that top of the bit is going right on top of that material. So that's how you use this handy little script to zero right on top of your material. And what's nice about this is if you use a tool measure system like I do with the proximity switch at the top and the touch-off plate, you can actually save this work coordinate offset in here. You can even power down your machine and re-zero, and you can come right back to the top of your material. So that's how that script works. Let me know if you have any questions.